So as we discussed earlier, if the first student were to drop out of class A, so there would be only 12 students. Because of that, we will have a new median. So the new median would be the average of the uh, central IQ values of the students. So now let's look into the median in detail. So the median is unaffected by the outliers, making it a better measure of central tendency, better describing the typical person, the mean when data are skewed. Still, if you see that here, just a minute. So this is where the median is pointing out. So if you see the median income of Indians is in and around here. So whereas the outlier is here. So if you compare the mean and the median will provide the better result than compared to the mean. So with this, we can say that the median is unaffected by the outliers. That's the reason. So mean better describes the typical person. So the mean is the better measure of central tendency when the data are skewed. Similarly, if the recorded values for a variable form a symmetric distribution, the median and the mean are identical. In that case, if the variable if the recorded values for a variable forms a symmetric shape, then the mean and median lies at the same spot. And here is that example. So mean and median are at the same spot. So in skewed data, the mean lies further toward the skew than the median. So that's where the power that's where the power of median comes into the picture. If you see that, this is the skewed data and the mean lies somewhere here at the center point, whereas the median lies towards the skewed data. So that is the reason the median is the accurate and exact representation of the data of the central tendency. So that's the reason I was telling the median will capture the actual measure of central tendency than compared to the median when the data are skewed. So the middle score or measurement in a set of ranked scores or measurements. The median is the middle score or measurement in a set of ranked scores or measurements, the point that divides a distribution into two equal halves. Data are listed in order. The median is the point at which 50% of the cases are above and 50% is below. So in a simplest way, it's the 50th percentile. The median is the 50th percentile. I'm repeating again, the median is the 50th percentile. So now let's take the examples from live data. Okay, so let me call up my soccer players. Soccers. So players. This is my players data. So what I want to see is median. I know mean. So height. So this is the mean height is 177.45. So let me check the players. Let me check median of this. It's 177. It's of course 177 is somehow, but before that, let me check that uh, histogram. Okay, this is actually it's taking a shape of normal distribution in that case. So we can clearly say that's the reason the mean and then median. That's what I just want to uh, try to prove here. So if the data is symmetric, the mean and median would be very close. So here the data is pretty symmetric, so the mean and median are exactly at the center. There is a slightest difference. It's 177.45 is mean, and then median is 177. So let's take other one. So players, this time it's a weight in kg and histo. Oh, this is skewed. It's not pretty much skewed, but still it's skewed, and this is how it's there. Let's check what's gonna happen here. So players, it's a soccer players. These are the soccer players and weight in kg. And first I'm gonna go with the mean, and it's 72.65. It's somewhere here. That's the mean of the whole data. Now let me bring up a median. It's 70. So there is a slight difference between this and this, because however the median is gonna truly represent accurately represents the data. 70 is the proper one, 72 is not, and because it's slightly skewed on left side. So let me go for the customer data. Okay, this time I'm gonna call for new data. What's that? It's called customer segmentation. CS, that's customer segmentation. Pandas dot read CSV, and customer segmentation, that's CS. Yes, this is what the data. So I want to see the age, annual income, and spending score. Not much worried. So family size. So these are the three. Oh, work experience also would work well. So let me go one by one. So CS of let me begin with age and hist. Oh, this is pretty complex histogram. That's okay. It's by and large looks like your you know uniform. So let me go for the mean here. Let me copy this and take a mean. It's 48.96 years. That's the average age. Let's see what this one says. It's a 48.0 because the data seems uh, pretty symmetric. Let's go for the other one. This time it's annual income in dollar. Yep. Okay, let me slightly zoom it again. So finally, so CS of this time it's annual income. Again, let me go for the east. Yes, this is slightly skewed right side. Anyway, let's see what's going to happen. CS of annual income, and I'm going to go with the mean. Yes, it's 110,731.8215 dollar. Now let's go for the median, and it's annual income. Sorry, it's 110045. There is a huge amount of difference between the mean and the median. So the median, so here also the median would be the accurate result. And I'm gonna look into the work experience also. Let's see how work experience is distributed across all the people. So CS work experience in years and hist. Oh, it's skewed on left. Let me see how it goes. Work experience and mean, it's 4.1025 is the mean work experience. And let's see what's gonna say, what a median gonna say. It's 3. See, this is again a representing, the median is giving the accurate and true representation of our data. If you see, our mean is saying somewhere here is the center point, but the median is saying somewhere here, because there are a huge number of around 800. It's too much, around 850 or 900 uh, of the respective entities doesn't hold any experience. They just hold an experience between 0 to 1. So that's the reason it's supposed to be closer to the left side. It's 3, whereas your mean is giving 4.1025. And it's proved again, when the data is skewed, the proper and the accurate representation of the central tendency of measure, the measures of central tendency is median. Hence proved.